The third, 14th and 69th terms of an arithmetic progression form three distinct and consecutive terms of a geometric progression. The next term of the geometric progression is the nth term of the arithmetic progression. Then n equals T3, T14, T69. A geometric progression. I have to figure out the next term of this geometric progression and then bring it back to the arithmetic progression. I know this is a plus 2d, a plus 13d, a plus 68d. I'm not going to do that. I'm going to define this as b. Geometric progressions get defined very well with the middle term. From here, 11 terms before, b minus 11d. From here, 14 to 69. 69 minus 14 is 55. This will be b plus 55d. Why am I defining like this? Because from a geometric progression, I like it. If I anchor around the middle term, a, b, c, I like it as b by r, b plus r. Easier. I can say b square is equal to ac and then simplify and then find d. So my life is easier if I can anchor around a middle term. So I say, hey, nice, interesting. So I'm going to anchor around this term as a middle term. From here, I have to add common difference 55 times to go here. 14th term, 69th term. Backward, I have to subtract common difference 11 times to get here. So b square equals b minus 11d into b plus 55d. Something to go with, something that I can simplify it and get some value of d. Let's see if we can get that. B minus 11d into b plus 55d equal to b square. So b square minus 11bd plus 55bd minus 11 into 55d square equals b square. 44bd equals 11 into 55d square. We are told this is distinct and consecutive terms. That means the common difference is not 0. They can cancel off a d. Or I get that 4b equals 55d. I'm cancelling 1d remains. 4b equals 55d. Nice. Or b 4b equals 55d. d is 4 by 55 times b. Nice, wonderful. What is the next term of the geometric progression? Nice. The next term of the geometric progression, this, and the term after that. That is b plus 55d whole square by b. So, looking for b plus 55d whole square by b. This is the fourth term of the geometric progression. We need to find this and then bring it back to this form. B plus 55d the whole square. D is 4 by 55b, which is nice, no? 4 by 55 into 55 makes it 4b. This is 5b the whole square by b. This is the fourth term of the GP. 25b square by b, which is 25b. This is the fourth term of the b square. This is nth term of the AP. So AP was anchored around b. B plus some number of times d equals 25b, or some number of times d is 24b. D is 4 by 55b. This into 4 by 55b is 24b. So 6. B gets cancelled. This number is 55 into 6, which is 330. So from B, we add common difference 330 times to get the next term. It's brilliant. We need to remember that for us, B is not the first term, it's the 14th term. From here, we add 330 times common difference. to get the next term. 330 times. So what term are we looking for? From here, 330 times the term to the right, or this term, the nth term is 14 plus 330, which is 344. Super tricky, very heavy duty algebraic, something where we need to anchor around one term, use the idea that if you have A, B, C in GP, then my sequence is B square equal to AC, solving for B square equal to AC. The other idea that we use here, you have three terms in GP, A, B, C. The fourth term is D, then we know BD equal to C square, or D equal to C square by B. We use that to derive that term. Then come back to the AP and then find how many times common difference we need to add. 344 is the answer. Properly algebraic heavy duty solving involved.